What are your questions on the homework? No questions? The last one? Thank you. Assignments. Here we go. 6.3b. Right, I'll read the last one right here. So if there's anyone before that you want, I'll gladly do that for you.
Number 13.
All right, so let me get this one first, and then we'll go in reverse, I guess. Okay. What? No. Calculator. Okay, so this is the last one, right? And they want us to factor it completely. All right, so this is going to be, it looks like it's going to be the sum of two cubes. And what I asked you guys to do was to do this first. Put them into definitely two cubes. That way you can see what the first item is and what the second monomial is going to be, I guess. First monomial, second monomial, okay? So if I take the cube root of 8, that's just 2, right? Now, y to some power of 3 gives me 6. What power is that? 2. So there's my first. Okay? And then over here, of course, the third root of 27 is going to be 3. So I'm going to have 3g. And then from there, I just follow my formula. So it should be 2y squared plus 3g. 4y to the fourth minus 6y to the third plus, what is that, 9y squared? Correct?
They all look like y.
They are y. Oh, no, they're g's. Thank you. That's why I thought it was, okay, my bad. So this is wrong. This is wrong. Thanks for saying something.
How do you get the second parenthesis?
I'll write the formula again for you. Okay. This should be 6 y squared g. Yg.
I am so done.
And then this should be g squared, right? Okay.
So why do you?
Yg is proper, right?
Huh?
Isn't Yg a rapper? Yeah. Okay. So. So here's the formula. So you see how I've broken them up into these two little parenthesis things? Whatever's inside of here is the first item. Whatever's inside of here is the second item. So all you need to do is replace these f's and s's with the corresponding values. So here you're going to take the first one, you're going to square it. Here it'll be first plus, times the second, and then plus the second one squared. So that's exactly what I did. If you'll notice, that's the first. There's a plus sign. That's the second. Second one, I squared it. I took the first times the second, which is 6 yg, or y squared g, and then the 9g squared. Cool? Questions there from anyone? That was 15. Someone needed 13? 14?
13.
13?
And 14.
13 and 14? I'll just throw one in there. Ooh. Okay. This one's going to look weird just because one of the items in there, one of the terms, is actually a binomial. But it should be just the same as the last one. This is all ready in terms of some cubes, isn't it? So that will be whatever's on the inside. On the second one, I do want to change that one though. So this will stay y plus z cubed minus, what is it, 5 cubed is 125? So there you go. So again, follow the formula. The first one is y plus z, and I'm going to subtract from that the second one, which is 5. Okay, so there's the first, actually in this case it turns out to be a trinomial, right? The next part's going to get nasty. Because I have to take this first one, this first quantity, I need to square it, which actually gives me another trinomial in itself, doesn't it? So here, I'll use different colors so you guys can see the different parts, because it's only really 3 parts, right? So the first one squared, it's going to give me y squared plus 2yz plus z squared. Okay. Now for the middle one, when I take the first times the second, which is this this y plus z times a negative or positive 5, it's going to give me a positive 5y plus 5z. It is. It's pretty bad. It's pretty bad. And then finally, I take the last one and I square it, don't I? Which is just
Oh my god.
25.
Oh yeah.
So
Where does the 2yz come from?
it comes from taking this one times itself. So if I did y plus z and I squared it, that's y squared, right? This is going to be a positive yz. This will be a positive yz. This will give me the z squared. But there's your 2yz. Okay. Are there any like terms up there? Can I clear this? I'm going to clear this. Let's see here.
You don't need to be forward to that. This helps my slides with this stuff.
Well, I'm trying to see because it does say factor completely. So I'm just making sure that there's nothing in there.
That's just
No,
really
that's just
ugly.
part.
Can anything be combined? No, huh? Ugh. But there you go. I know. They're not the nicest ones. Now, if you wanted to, you could have left it so you can make it simpler on yourself. I don't know if the computer would have taken it, but here, for that first one, if you just went y plus z squared, and then for the green part, just went plus 5 times y plus z, and then plus the 25. So that's, I don't know if that's another thing that the computer would have taken from you. Actually, you want to punch it in, see what happens? I'll punch it in.
Is the study plan like ready for this? Because I tried to do it and it's still on chapter 5 where you have to take those quizzes and stuff.
You can go into the little bottom link and go in there yourself.
Okay.
Yeah, you don't have, whatever you see in the front is just because I think that's the last thing you should be working on. But if you click the blue link at the bottom, you can go back and work on whatever study plan you want. Okay? Let's see here. I want to do this real quick. So it's going to be, what was it? It's y plus z minus 5. Correct? Parenthesis, y plus z, shift, parenthesis, quantity squared, plus 5 times x plus, well, it's not x, it's y. Did I put an x somewhere else? No. Y plus z, plus 25, close parenthesis. So this is one thing I said, if you don't expand it, I want to see what it does. Okay, cool, it took it. Liked it. So I guess that would have been easier to do than to expand everything. Okay? You guys want to see the next one then also, 14? What is that? Any ideas? Now that we've done some of these, any ideas? You guys are talking like you guys know how to do this already, and there's no reason for me to be answering questions. Okay, if that's the fact, then I could just go on to the next lesson. Any ideas here? We've already done something like this.
Separate.
Separate them into two cubes. What would they be?
C squared.
C squared with 4. And there's your values. So C squared minus 4. C to the 4th plus 4C.
Plus, right?
Yeah, plus, right?
Isn't that the next one too? Or is it-
Yeah, they'll both be pluses. Well, this is minus. They'll both be addition. So this would be squared plus 16. And truth be, this is actually factorable further. Notice that this first one is actually the difference of squares again. So this would become C plus 2, C minus 2, C, is that factorable? Square root of that, square root of that, no. No. So this would stay 4 plus 4, C squared plus. So be careful with your first one, because sometimes you might end up with something that is still factorable further. Sneaky. Who asked for this one?
Yeah.
Is that what was happening? Were you putting this in and got it wrong? Because you got to go further. Let me try that. Let me put it and see what it says.
No, I just have my signs mixed up.
Okay. So we said, I want to see what it tells me. C to the 2nd minus 4, close, open. C to the 4th plus 4C to the 2nd plus 16. Yeah. All of the answers correct. It's not correct form. So let's see here. Before you don't move. C minus 2. C plus 2. Hey,
I think it separates
say that one more time.
it breaks it.
This factors out further?
Well, because here it's like there's two triangles.
There's two trinomials?
Yeah,
Let me go back and look at this then. See that for, so C squared minus 4, C4 plus 4C squared plus 16.
it makes it C squared plus 4 2C.
In order for that middle one to factor, this would be C squared and that squared was 4, right? So if I multiply and double, that's not the middle one. But if you took the square root of everything on that side, everything does have a square root, doesn't it? That shouldn't be it. Because it's the addition, not the product of. This definitely breaks up into this. And you said it's two trinomials?
Yeah.
The only way that could be,
It's like they switch the middle term and the last term. So the 4c squared and the 16, it's like they switch it.
this is over here.
Yeah, that's the only way I can.
Uh-uh. I know. Oh, I see what you're saying. Yeah, but that's not. Because even if you took the square root of 4, it would be 2, and 2 times c would be 2, and you squared it up at 4, not 16. But still,
For this, they
let me see what they did. That's interesting. All right. Continue. Continue. There's our difference of squares. Oh, they did difference of squares. Whoa. That's interesting. Whoa, no way. That's cool. Okay. Okay, let's try that. But I'm gonna come back to that because that you should still be able to do something like that. Let me copy, paste. Okay, so I'm gonna do this one and then I'll come back to the other one. So what they did here was they said c to the third squared minus, what was it? What's the square root of that? 8?
Yeah.
yeah.
Square root of that is 8. So then if we did this, you'd have the difference of 2 squares, which would give you c to the third plus 8 and c to the third minus 8. And that's the sum of 2 cubes, and that's the difference of 2 cubes. So then you would have, excuse me, c plus 2, c squared, not plus, minus 2c plus 4, and then here we would have c minus 2, and then c squared plus 2c plus 4. So this is the part I'm interested in, because I already have this the other way, that, Did I not do this one correctly? First one squared is c4. First times the second is 4c squared, 16. Two numbers that multiply to 16 and add up to 4. No, but they actually have two trinomials, don't they? Okay. All right. I'm gonna have to keep working on this one. Is there anything else you guys want to see? Here's the other one. So they went with squares instead of cubes first. Is there anything else?
So how do you know when to
Yeah.
You might want to go with the lowest first, with the lowest degree, and see how that breaks up into different pieces, and then go up to the higher degrees. That's the best advice I can give you. So if you can find a cube difference of squares first, do that, and then go to difference of cubes. And we kind of do that even when we're doing prime numbers, when we're doing prime factorization. You always want to start with the lowest prime, and then work your way up to the highest prime. This one's killing me though. There's got to be a way to do it the same way. So there's nothing else? Let's go on to the next thing. We need a test by Tuesday next week. Do you guys want to save the test just? Yes.
Can we start him?
That's what I'm saying. So do you guys want to test Monday, Tuesday, or Friday? Well, we won't finish this by Friday, so.
Tuesday, if we do test.
You would still do more math.
Oh, yeah, Tuesday test.
Yeah, so test Tuesday. That gives us time to do today's lesson and then tomorrow's lesson. We can do that one and then we can review Monday. Okay? So let's get this party started. Section 4.
Wait, are you gonna make us do the study plan?
Sure.
Really?
No.
I'm not asking to.
No, you should be doing it. You should have been doing it.
But,
Well,
yeah,
I'm saying if you're gonna.
I'm not going to
do it,
require
I'm
it
just
again.
trying
You
to
should have been
figure
doing it.
we do it, but it's hard to get, like, what you need to get to.
Right. What I'll do is I'll just give you the review. The review quiz.
I'm gonna start at the very moment.
Well, you should have been starting it from the
I
very
can't
beginning.
never pass it. I get one wrong and then I just get mad because
Okay.
I do the same one 8 times.
Callie, remember fourth hour to fix that. Because it should be more than one. All right, cool. So factor out any common factors, factor binomials, factor. Didn't we do this already? Well, let's see. It's probably different example type stuff, okay? So we're still factoring binomials. We're still factoring trinomials. Factor out common terms. Factor polynomials of more than 3 terms. So here's kind of a small process that you can do. Always start off by factoring out the common factors. Try to make that polynomial smaller as you can. If it's a binomial, then try to see if it's a difference of squares or a difference of cubes and all that good stuff. If it's a polynomial, then we're going to have to refer back to that old technique, which is the first one's outside and say last, or that FOIL method. And then check the factoring to check your work, make sure that multiplies out again, okay? So, can we factor out a common term here? 2x, right? So we factor out that 2x, and this is what we end up with. Then we can take a look at the inside. It's a trinomial in this case. Is that factorable? And here the answer is no. Okay, the only way to get a 2 is a 1 and a 2, so that would make you done. In this case, is there any common terms that are factorable? It's the p minus q, so you could factor that piece out, like such, and then you would have over here, pq, and then whatever's left, 12 minus 7n. So it's still just factoring. Still just factoring. Okay, now let's take a look at binomials. Okay, check for these things first if they're binomials. Okay, I want you to notice that there's no sum of 2 squares, because can you factor them? Not the sum of 2 squares. The sum of 2 cubes is hunky-dory. There's your formula for it, but not the sum of 2 squares, okay? You should already have those. Is this factorable? Well, that's the square root of that is 6x, right? The square root of this is y, so definitely that would give me 6x minus y, and then 6x plus y. And then we'd be good to go. And there's my differences. Here's my differences. Okay? In this case, is this factorable? I can make this 2t, the square root of that is 2t. The square root of 1 is 1, real nice. So I can factor that right into 2 conjugates again, just like up here. No, I cannot factor this, because that would be the sum of 2 squares.
Make it
It's-
sound like we could.
I will always try to do that to you.
I didn't think about it. I think we can on the test.
No,
You told me.
no. Hopefully that makes an impact. You're like, oh, wait a minute, Munoz was messing with me.
Why can't you?
Because it's the sum of 2 squares. Okay. If we try to, let's say if you weren't going to factor this, which is the sum of 2 squares, into something like this, well, didn't this give us that?
Yeah.
So how's it possible to get this to give us this and not what it was supposed to over in this side? It's going to give us a minus. It's not going to produce a positive. So the plus is not factorable. I mean, not factorable for the skills we have right now. Because you,
It's gonna get worse.
what?
It's gonna get worse.
Yes.
You said it's not.
Well, all I'm saying is, well, all right, let me take that back. You've already dealt with imaginary numbers. You can factor that sum of squares, but you're going to get imaginary values.
So you get like 2i.
Yeah, you're going to get imaginary values, complex numbers.
I really hate I.
Well,
Raza did
but-
not teach that last year. It was like
It
one
was
day,
just really
and then
hard
we
when
had
he
tests on it.
explained it.
I think Mr. Shabir
It's easy.
I know it is, but like
He
just
just
when he
told us what it
explained
was.
it, like he would take it, he would drag
That's
it
all you need to
on.
know. Pi is just radical 1.
No, I didn't know it was a radical one.
Does somebody have to teach you pi?
No,
No, that was.
Raza never said I is a radical one. Like he never
Oh.
said that. He was like, and then this is how you
Okay,
do it.
all right, let's move on. Is this factorable? Cube root of 125 is 5. So this can be 5x and this can be 3y. So definitely I can use my difference of cubes formula to factor it into something like this down here.
Ew.
Okay? Factoring trinomials. Okay, trinomials. Remember, you're either going to have the perfect squares. Okay, so it's going to be the two squares where they're a perfect square where they're being added, or a perfect square where they're being subtracted. Otherwise, if it doesn't follow that rule, then it's everything else. And this is what I was talking about. So, how do I check if this is a perfect square? Do you guys remember? Go ahead.
You take the square root of the first.
Square root of the first one. What's the square root of the first one? 4m, right? And then I'm going to want a plus in the middle, correct? Because of that 56. And then what's the square root of 49? 7. So here's what you do. What's 4 times 7? It's 28. And if I double it, do I get 56? So then I'm good to go. There it is. Okay? Jacob, you got this down? Any other questions then? Okay, cool. How about this one? Is this one going to be a perfect square? No, it's not, Miss Munoz. Okay, I can tell you it's not because 5 doesn't have a square root. It's a prime number. So there's no reason for me to continue. Okay, now can it still be factored though? Is the whole problem itself still factorable? I know it's not going to be a perfect square, but is it factorable? You might want to use your calculator for this. You guys remember how to do it? How to check it? You're going to go negative 13 squared minus 4 times 8 times 5. What's 13 squared? 169? Minus, what is that, 40 times 4, so 160. That gives me 9. Does 9 have a square root? Then that's definitely factorable. So I have to just think about it. Okay? So again, I'm going to go back to my rules. The only way to get a 5 is a 5 and a 1. Well, that's a horrible 5. A 1 and a 5. So let's see here. And then I'm going to have a t, something t, right? So let's think about this. What are the factors of 8? 1 and 8. So let's see, if I put a 1 here and an 8 here, want to try that out? Okay, so let's see here. What's the outside product give me? 5. And the inside?
8.
If I combine them, do I get a 13?
Yes.
Oh, there you go. So this will be 1t squared. Not 1t squared. What am I talking about? This will be 1t, and this will be 8t. And because that's negative, remember I combined them? Both of these have to be negative values. But there's your factor right there. Yes, sir.
And that right there is b squared minus 4ac.
Yeah, that's called the discriminant. Remember from the quadratic equation? You guys remember the quadratic equation? That's the discriminant. Square root of b squared minus 4ac. Now, personally, if I was given a choice, and I already did that work, I'm just going to finish that. Because all I have to do now, because I know this is a 3, right? All I would do, okay, what's the opposite of b? Well, that's 13 plus or minus 3 over 2 times a, which is 16. And then finish that up, which is your quadratic equation. You'd still get the same expressions. But because you're factoring, that's not the route to take. Not this time. Okay? Exercise that tool there. All right, moving on. Is there another one? Nope. Bye-bye. Okay, how about here? Is it factorable? Is it a perfect? Is it a perfect square? No. Are you sure? They all have a common factor of 3. X squared minus x minus, what is that, 21? So is it factorable? Still no, right? Still no. But I definitely want to get that common factor out first. Now the question is, can I factor that? Two numbers that multiply to 21 and give me a difference of 1. The only way to get 21 is 7 times 3, right? And would that give me a difference of 1? That'd be a difference of 4. Or if I added them? No, so. But to say something else. No, they're factoring it. What did they do?
When you took out the
my
3,
God.
you forgot to put 2x squared. You put x squared.
Oh. Thank you. No, where?
Yeah, because you just.
Oh, in the first one. Thank you. Well, that makes a difference.
Like that.
It does. So let's see here. We could try out the quadratic, see if it does, but obviously we saw that it's going to be factorable. So let's see here. 2 times. Now, the only way to get a 2 is going to be x times 2x, correct? So what do you guys want to try that out with? 7 and 3 is the only ones we thought of, right? So where do you guys want the 7? Where do you want the 3? I'm going to say 7 here. Because if I put the 7 here, it's going to give me 14, isn't it? And then with a 3, there's no way I'm going to get there. So 7, 3. Now what's this outside? 7. Inside is 6. If I combine them, I get 13. That's not what I'm looking for. But if I subtract them, I do get a difference of 1, don't I? So I want the 7 to be a negative, and this to be a positive, and there you go. And that's not a 2. It should be a 3 right here. Sorry. Sorry. Boop, 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 boop. Polynomials for more than 3 terms. Yeah. Ideas here? Here we're going to have to resort to our factor by grouping. Okay? So in this case, I'm going to have to split this up somehow. And there's no real good choice here, so I'm just going to split it right there, okay? So when I look at the first part here up front, what do they have in common, those 2 pieces? Just a p? So I'm going to take p out, and that would leave me with p squared minus 2q squared, correct? And as I look at the other side, what do they have in common? They have a q in common. So I'm going to take out a positive q. Let's see what that leaves me with. That leaves me with a p squared minus 2q squared. Oh, look at that. What do those 2 have in common? They have that inside piece, don't they? So I'm going to write this as p squared minus 2q squared times what's left over, which is the p and the q. Now, is this the difference of squares? Can I factor this further? Well, how do I check? Is there a square root of 2? Oh, no. So we're done. Callie with the save on the 2. Go, girl. Next semester is going to be Callie and Christopher Corbett teaching this class. All right, cool. We got another example? Yeah, we do. Cool. How about it? I'll pass on that. All right, how about here? Same idea, right? Now, if I do this, let's see here. What does the first 2 have in common? Actually, hold on. Before I do that, I'm noticing that there is a y square there. Is this factorable as a perfect square? Do you see it? Before I did that mumbo jumbo, is it? The square root of this is going to be 3x. The square root of this is 4. 3 times 4 is 12. If I double it, I do get the middle piece. Okay, so you got a couple of choices here, don't you? So let's go that route instead, because we've done quite a few of these. So that means that this is going to factor into 3x plus 4 quantity squared minus y squared, which is technically y squared. So now I have that first term and I have that second term. Okay? I just have to follow the formula at that point. Okay? Do I need to finish it? Good.
Wait, what?
Here.
You're not paying attention.
Finish it? Okay. No, I was just asking, do I need to finish it? No one said anything.
This is actually cool.
Oh, I didn't hear you. All right, so what was the formula? First minus the second, right?
Yep.
So the first is 3x plus 4, and the second is y, so I'm going to go minus y. And then we did learn that you can punch it in just the way it is. So then it's the first one squared, so it's going to be 3x plus 4 squared, first times the second. So it's going to be plus y times 3x plus 4, and then finally plus y squared. Sorry, it didn't fit there, but you can fit on your paper.
Oh man.
Okay, but it's not really that bad. It's just, this is a number, that's a number. And if you want to do this, you can too, look. See, so you can see, oh, it's just a number. Okay.
What? Okay.
All they're making us do is think about all this differently.
How much worse does it get from here?
I just want to practice more like these. I don't know why this one was so hard.
Rational. That's where they put those on top of them, divided by something on top of itself. And it's not even that bad. It's just recognizing. I wonder if we would have gotten to this the other way.
Why
Try
was
it.
this one like really hard?
Try it. Let's get through the whole presentation and then we'll try it.
He's looking directly at me though.
What?
Never
You
mind.
said do more like these.
No.
She said, why is it so hard?
I don't know why that one was so hard.
Oh, I ignore that kind of talk. It's not hard.
Well, it looked really easy, but then you did all this stuff, and I don't know where you got it from.
Where? Here?
Yeah. I don't know, like, how... Okay, never mind, actually.
I can
Yeah,
explain
I'll figure
it.
it out. No, I'll figure it out.
No, I can tell you, right? It'd take me about a second. You'd take about 30
Okay, can you just start from the beginning real quick?
minutes. Okay.
No, like, yeah, after, you can just explain that.
I can explain this.
Yes, just explain it, please.
First,
Okay.
minus the second.
Okay.
First one squared.
Well, why'd you put the y there?
Because that's the second term.
Okay.
Right?
Okay, yeah.
Okay. And then here is, and then I have to do here, I have to do first one times the second. Doesn't matter if I go second times first.
Oh.
It's commutative, right? I just put this one because it's nicer. I could have put the y at the end if I wanted to, but it looks weird. And then finally, plus the second one squared.
Alright. That's all I need.
Good. Thank you. See, it didn't take long.
She said, I'll figure it out. And it'll take you like 30 minutes. I just like,
You have nice hair. I don't want you to come in one day with like a bald spot. What?
don't lie to her.
Just so
I don't want her to come
all
with a
day
bald
long.
spot. It's rude. You guys are gonna lose your hair at 20. Watch. Jinx yourselves. That'd be me. That's not nice. All right, cool. How about here? This one we're gonna have to do some rearranging. Okay, because I can see that this is a square, right? That's a square, and then I got two cubes going on here. So 64 a to the third plus b to the third plus 16a squared minus b squared. Because now I have the sum of two cubes and I have the difference of squares. So if I want to factor this bit right here, okay, looking at this, that would become, let's see, what's the cube root of 64? 4. So 4a plus b times 16a squared. And I'm just using the first second rule, right? Do you see it?
Oh yeah, sorry, I was writing.
Right, no, but I'm just saying, right now all I'm doing is the first second rule. It's first one squared plus first times second plus second one squared. So here's the first one squared. That's a plus, so there should be a minus 4ab plus 16. And then over here I should have plus, and then here I've got the difference of squares. So it should be a 4a minus b, 4a plus b. Now, why did I put a plus between those and not just multiply straight across? This is why. I'm hot. I grouped these two, and I grouped those two. And there's still a plus in between them. See that? So it's like I just took these, I factored them, but they're still an addition between the two. Oh, look at that. What do they have in common now? The 4 plus AB, or 4A plus B. So I could take that out, so it'd be 4A plus B times what's left there, which is 16A squared minus 4AB plus 16 plus 4A minus B. Holy smokes, that's horrible.
Yeah.
That's bad. But it is what it is. Is there anything combinable down there? Holy smokes. They're not playing nice now, huh? Forget it. You like the fact. This one we should make one of these, huh? Exhibit memes. I put some polynomials in your polynomials so you can polynomial the hell out of the polynomial.
What?
It's an exhibit meme where they put like something inside of something so you can do something.
Where's the first term, like, in the second term?
I just skipped that part. I'm sorry. So what I did here is this became, let me use a blue, okay? So when I put this became 4A cubed, the first piece, plus B cubed. So that is what gave me the red part. And then over here, this became 4A squared minus B squared. And that gave me the black part. Okay.
So they're separate. That's first term. That's second term.
Right. So that's why I kind of kept them. But when I got at this point, notice that this one and this one are the same, right? So I factored it out and then put back everything that was left behind.
So if you have two the same, you can factor it out, put it right there, and then. Okay. Three of them are the same though. 4A plus B. Oh wait, no.
It's a 4A minus B.
Oh, okay.
You see
Now
it?
I see it, yeah.
Good.
It's a science.
Put the factor in your factor so you can factor the factors out of the factor.
Makes my head hurt.
Oh, that's wicked. Come back. Oh, there it is right there. See it? 16A squared minus 4AB.
It's B squared, not 16.
Where did I get 16? Did it turn into a 4 somehow?
You turned it.
My bad. Alright, but 16, there's 4A, there's minus B. Why? At what point did I turn it? Right here. Oh my god. Thanks for saying something, guys. Right here. So that should be a... Then that needs to be B squared.
Say it.
No, I was scared.
Scared?
I was gonna say it and I would be wrong.
No, I could be wrong. Not Jesus. Not Jesus. That Jose. Pretty close. You're his daddy. Alright, cool. That makes us done, guys. Assignment will be ready in a bit. Hope it's recorded.